All right, let's try and use ChatGPT to figure out how to get our two images aligned. What we have here, by the way, my son sent me the northern part of Villach in Austria, and he'd already sent me the southern part. And I need to combine these. This is what it looks like with the trees and buildings on. That is the surface model. We're not going to use those at first. This is the satellite model, and this is the area we want because this is Corinthian College that we're modeling. And that's what we need to get. So the first step is going to be to merge these two images together. And how to do that is something we're querying ChatGPT about. And it says go raster miscellaneous merge and input two layers. So raster miscellaneous merge, and the input layers would be the north side, the DGM, north of, that's that one, and the 517,200, that's the south side there. Okay, that's what we're merging. And the output data type would be, I have to ask for the output data type. Does it give us anywhere? I'm going to call it Corinthia DTM merged. We can do that. Copy that. As parameters merged will be file, and then we can put that here. That'll be my merged, but leave the rest default. All right, so let's go ahead and run that. These are merged, so we don't need this anymore, or this. That is our merged layer. Now, let me just check and make sure. You can see the height here, 503. The river is somewhere down at 485, 490. So those are the river areas down there. And then there's these higher landscape areas. Nothing very high at all. So maybe this a little bit here. All right. So we have a merged area. That's fine. Now, for this is the clip extent that we want. So clip the DTM to the satellite. Your satellite layer is there. We want the terrain to match it, so we do raster extraction clip layer raster by mask layer. So for on this, it is raster extraction clip raster by mask layer. Mask layer is going to be the satellite, if we can find it. I can't find it. Alright, so let's see what it says to do. Mask layer. Yes, but there is no mask layer here. Refresh. Select file. Sorry about that. So the satellite. Satellite is here. Satellite, here you are. 31258. Now, target extent. Maybe we'll just leave it not set. These are all optional. And then you need to give it a name. Where is that? Flipped mask saved to temporary file. We're going to save this as flipped. Actually, DTM merged flipped. So that. And run it. Could not find the source layer. That's weird. Alright, let's ask. Alright, so it's not allowing this to be loaded because the mask layer it expects is a vector, not a raster. So ChatGPT is suggesting that we do raster extraction, flip raster by extent. So we're going to go raster extraction. Instead of clipping my mask layer, clip by extent, and then the clipping extent could be that. It would also be calculate. And I need to see what it says to do here. Calculate from layer. Okay, so here clipping extent would be calculate from layer, and then we'll use the satellite 31528. And then we will put the extent, clip extent, save to file. Let's say, what were we saying it was called? DGM. Let's use whatever suggestion it gave so we have a trace for it. Match the extent. Check and match the extent. So when you do this, you say use current map, calculate from layer, and calculate from here. I guess we just need to give it a I want this to be in fine. Okay, now let's run it. Now, where did it put it? There's the clip. So this can go, and you will see that matches that. You should also do that for the building layer. So I want to merge my DOMs. Don't need that, we want this, and we want this. And let's try this again where we're going to clip it. So raster clip by extent. Input layer. That's not what we want to do. We want this and this. And we want to clip it by extent. But no, we need to merge them before that, right? So we did raster, and it was miscellaneous merge, and input layers, would be DOM north of, and the DOM, if I took that one there, and then we're going to merge these. And there's merge, I need to rechange the name for this. There's the name there. And this is DOM, Corinthia DOM's merged. And this is what I'm going to take. I can get rid of that and that. It's the clip. It's the underline there, and then I'm going to do the same thing with this. I'm going to take this, and I want those buildings. So taking this, I'm going to say raster, convert, no, extraction, clip raster by extent, and the clipping extent will be calculated from the layer, and the layer will be the satellite. And then give this a name, which would be Corinthia underscore DSM, digital overland to English, underscore clip, and I'll have both of these. I do need to tell it where to put it. Alright, so the DSM clip now. Get rid of this. There's my DSM clip. Let's move this one up. Oh, didn't do it. Sometimes you gotta be patient with it. Should have the line first. Alright, so I got that on top of that, buildings, and I got that on top of that. Alright, so far so good. Now, to get it out to Unreal Engine, we need to resample them. Alright, before we get to exporting, I want to show how we now are going to get the heights for things. This shows you that the river is at 485 and this building is at 490. It's 491. So if the river is 485, then you've got about 5 to 6 meters here. But that's not necessarily going to do us. We want to get the DSM clip and subtract this clip here. So here, when we look, 485, 501, it's 490 on the ground here, right? And when we look here, our building is 490, 509, right? So to get these, all we have to do is let QGIS do the math by using the raster calculator. And we would say that the DSM clip is going to be, we're going to subtract from that the DOM or DTM clip. If I can find it. There it is, DTM clip. And I should have put a minus in between. There we go. And then call this the Corinthia DSM minus DTM flipped for heights. Let's just and then say OK. And you get another one. But what this has in it is the heights of things. So this building is coming in at 21. our college is coming in at 15.4. The river shows 0 because that is the ground level, so to speak. Okay? And then this tower for the waste-to-energy plant is a whole 49 meters above the river. So that's how we would know how tall things are. These trees, 19 meters, pretty big. These trees, 9 meters, ones along the river. 15 meters for these, for the old trees. The ones on campus, 3.2 meters, not so tall. This tree here, 5.9. This one here, 2.8. So we can get even the parts of the building with the back terrace is 4.8, whereas the auditorium is 7. This is 15. This part here where the cafeteria is about 6. Down here, it actually is an open space that drops right to the ground. So that gives you a good idea of how things look. And if you clicked on the satellite, you wouldn't get any information. But here's a trick for QGIS. If you click on the clipped subtraction so that you have those heights, now you can look at the building. You can see different parts, these skylights. If you want to look at this particular that's odd. So somehow this side comes in higher. This should come up higher, shouldn't it? That's 18 as opposed to right here. So this slopes up, obviously, because down at the bottom, oh no. Right, so this is another layer then. This is an 18 meter layer, whereas this is a 16. Same thing here, 18 meters for all this. This is back down to 15, this is down to 15. So you can get a sense of the building. Here's where it looks like it slopes up a little bit. 6 goes up to 6.7, peaks at 6.8. There's that little garden down there. It's got some trees, but if you look at the bottom here, it's actually lower than the river. The trees then are here, trees are here. And then you have this back terrace area, and you have this tree, and you have this path, and of course the river. So very useful to be able to use this layer of the difference and be able to look at heights. Okay, pause this a moment. Oh yeah, and I wanted to show too, if we look at the waste to energy plant, there's that smokestack. Okay, that's shown on this. Smokestack is going to be higher if I can find it. There it is. Let's see. Oh, that's odd. Let's see what happened here. Oh, they're not matching up completely because that's the one that's 48. And when we turn this on, yeah, what it seems is that there's some kind of perspective issue going on with the map, because that is where the actual smokestack is, and the rest of the building is lower. So the map isn't really, however they took the photograph, it's not looking down completely orthogonally. But it is there that you have the 48, as you can see. The areas there. And again, this is 1 meter resolution, so you're always off by about a meter. Okay? But fun. Alright, now we've got to figure out how to get this out as a square that works for Unreal Engine. Alright, so to make these the right size, we're going to take the DTM, take this, and we're going to go to raster projections warp, and we'll take that and the source optional, we don't need that. What we're going to warp to is, we'll go back to ChatGPT. Set width at 4033 and height is 4033. Yeah, so where is the width and the height? How do you find the width and the height? I'm going to have to ask. So ChatGPT is suggesting that I go to raster projections, not to go to align rasters. And then from here, I'm supposed to use a reference layer and then fix this. So I'm going to check ChatGPT on this. All right, so it's saying to make the input layer be the satellite image. So let's do that. Let's see, where's our satellite? Satellite, there it is. All right, so this is going to be the input layer, and raster layer selected, and then we're going to have the DTM clip. Got it. Leave everything else alone. I'm going to go create a new thing. Alright. So we need to make it satellite. So where is it going to be? Extent. Doesn't have anything else or where to go. Let's run it. Let's see. Output is not configured. Where's the output? See, I don't see it. So when that happens, I just ask chat because I don't know. I can't see something. I'm asking it to pause at each level and just give us the answer. You add an input raster, you didn't tell me where to save it. 3 dots next to input layers. Really? So here, that makes sense to me. Get again. Figure raster. That clear selection. All we wanted was the input layer to be the satellite. Right? Where did it go? Figure the raster. Please select a single layer. Is it under advanced? No. Nope. Reference layer? No. So it's not telling us clip to extent. Optional? No. Extra layer satellite. The empty cell under output. I think it's having trouble, so we're just going to have to let it know where we are, because something's wrong. I only get this on the free. This is what I go through every day, constantly asking. Clarifies what's happening. Made a cell, didn't it? Figure asking. It's fantasizing again. Please select a single letter. I'll pause. Alright, well, ChatGPT is letting me know that we're having a UI quirk error, so it's suggesting a different path. So let's forget about this. I'm sorry to take you down that rabbit hole. It is suggesting that we warp this, so we go to raster, not conversion, we go to projections, warp, which is a reproject, and then it's telling us to take our clip and resampling, use bilinear, wherever that is, elevation, let's see without elevation, here, bilinear, okay, and then after choosing bilinear, scroll down to georeferenced extent. Here's that georeferenced extent. Okay, click the little extent button, calculate from there, and pick who am I picking? I'm picking current DTM clip, which is exactly the one that I'm using. So, click from there, DTM clip, good. And then, now the important part, set the output resolution. It's going to be 4033. Compute pixel size. Right click this layer, properties information. Oh boy. So without ChatGPT, we wouldn't know how to do this. Isn't that something? So properties, and we want information, and then tell me the numbers you see for width and height. Let's see. Yeah, width and height. And then width and height. Yeah, 1250. So I guess you're always going to have to use ChatGPT or some other AI to do this. And then it'll calculate. My oh my, who knew it would be so difficult? So, what do you come up with? Compute the unreal scale. So how? 1250, 1000 at 1 meter, so the terrain is there. If we force it, we'll distort the terrain. So we must square the extent and reset. What's going on? Draw a square. Oh god. How do I preserve that square to use on my satellite and other images so they are uniform? How do you do that? Yes. Save the square as a polygon mask. Okay, so create a shape file. Okay, so can't do this yet until we create a mask. So we're going to go layer, create layer, a new shapefile layer, and we will call it Unreal Square Mask. SpongeBob SquarePants. Unreal Square Mask. Maybe it's easier to read if I put these underscores in it. Alright, let's make this. The geometry type is going to be a polygon. The name, does it need a field? Just call it identification. Just call it ID. And then fields list, doesn't really matter. Oh, that doesn't have any. Ah, shoot. New field. Let's call this name. I don't know. Yeah. Alright. Dimensions. Here, use the same one, so we've got to make it the same as this here. This is the 31825 Austria. That's what we're using. Right. So I now have an Unreal Square Mask that I can use, and I'm going to draw on that. Drawing a polygon, and I'm going to make a square. But how? Like I'm supposed to know how to make a square? And that, oops. Square attempt 1. I don't even think that is a square. So how do I make it a square? I'm going to have to ask. Alright, so alright. We'll find out. Of course, the idea is to not have to eyeball it and let the GIS do the math. You should never have to draw a square by hand. So we open the DTM properties again. So let's go. Close this up. Compute the square size. Square should be 1250 by 1250. Flip raster by extent. This sounds so complex. First it was having me draw it by hand. Now it is not letting me draw it by hand. So let's try this again. Compute the square size. So we take the DTM clip and we open up the properties, the information, and then what? And then you should see something like X max, X1250 there. 1,000. Large dimension is 1250. This must be 1250 by 1250. Use clip by extent. Input raster. So extent. Clipping extent should be here. DTM. See something like X min, Y min. When am I going to see that? Oh yeah, there they are. Those are the X and Y's. Okay, so rather than getting it wrong, not sure what this thing is trying to do. Let's send it a picture and see what it comes up. So let's see what it has to say. And it tells us that thinking, out thinkingness. Come on, you can do it. So one more time for this one. Edit the numbers to make this one. The raster must be also 1250. Change the y-max. Currently place it with this. So, this procedure, we have that and that. Y-max. We have to figure out what Y-max is. So there's 49, 1, 250, 49, 2, 1, 6, 4, current replace the 164 with 250. The 163 stays the same. So that's all we're really doing, because we're saying that the extent here, 491,250, and this 492,500, that's like adding 1250 to this square, and then we're adding 1250 to this square. That's what we're doing. And that's why it should be 49,250, 49,1250 to 49,2500, and 16300, 0.5 to 1642500. It's a perfect square. So we'll need to square this off. Save 2. Alright. And then run this. And there's the square. Oh, yuck. But it did. I am not happy with that. Let me remove it and let me add it again. So if we add a layer, add master layer. Should be able to see what we just created. Square. Yeah, ouch. So we made always problems with this. Look what it made. Tell me that's normal? Really? No data outside of black. It will behave correctly in filling. Fill no data. Really? Master analysis. So much to do. Alright. Raster analysis. Here's fill. Fill no data. Alright, raster analysis. Sure learning a lot today. Input raster is the square, leave the default distance is fine. Output is filled. And then alright. Let me try it. And then the filled layer doesn't look any different. If we do the properties, it should say yep. This one is 1. Yeah, again. So I'm going to get rid of ugh. Alright, you, get out. Get out, get out, get out. And you, get out. I do want to see, by the way, does it have different height values that we just can't see? Like that one says 0, but like the river was over here, and if we put the satellite on top of it, turn on the satellite, and keep using this, 485. So it didn't lose any information, it just made all this. So I suppose I can keep that square because it's got no data information. I just create a cliff. So what we really wanted to do was to take the DTM cliff, this one here, and redo it as a square. So when we do raster and then extraction layer by extent, and tell it that the clipping extent is calculated from its own layer. Clip. And we're going to change these to make it only 1,000. So what it's suggesting we do is keep present rate set to the x. Center x is 191.75, half of 1,000 is 500. So the x min is going to be this, the x max x min, and then the x max is going to be 49.2. And then the y min is kept as it is, and then run it. Okay. Here's the one that we just did. Oh, it's still calculating. Alright, let it calculate. Still calculating. And waiting, and waiting. Alright, well, it seems like it created it. Created a square. So, turn this off. Square centered. Yeah, it doesn't even show up. Wow. Ain't that spectacular. There's clearly something wrong here. I did something different wrong. Yeah, it's probably my bad. Because it went way out of bounds. So, gotta try it again. Alright, so it does seem to have worked for that one. I need to do it for the DSM as well. So, we're going to once again go to raster. We're going to go to flip raster by extent. We're going to use its own. Oh, well, we might as well use the Corinthia DTM square raster that we made. Square center. Let's save this as DSM. Let's try this and run it like that. So that, and we have that. So those are now matching. Good. And then we can do the same thing for the satellite. So we get the satellite, and we're going to go to extent. Use the same thing. Calculate for layer. Use the DTM square centered. Save the file and call it QGIS. So a lot of running good here. So now, if we take this off, well, that's weird. Maybe I didn't select the right thing. Seems I didn't. Okay, so we're going to take this raster, flip raster by extent, make sure it's the satellite that we're using, and then calculate from layer and use the DTM square centered, and then let's redo this. gosh, it's nowhere even near. It's nowhere even near it. So something went drastically wrong. So now that this square is way out of bounds. And so H shows up. We have square centered. We have the DSM on top of that. But we don't have a satellite. Why? I do raster, and I do clip it by extent. The clipping extent is calculated from this. Override the projection, maybe. That's what I want to do. Save to file. Just doesn't show up. It's like it's way out there. I'll have to tell you about it before doing that. Alright, so maybe it's got a different CRS. So when we look at the DSM, for example, or the DTM, and we look at the information, layer CRS is MGI Austria GA, right? And here, the CRS is MGI Austria M31, as opposed to this one, GKM31. Well, it is the same thing. What about this one? Let's see. I don't get it. Complete. This one here is M31. MGI. So I'm confused. So if we go to satellite and we go to properties, it tells us that it is in this. So I'm just going to tell ChatGPT. So the problem is pixel size is 0.2, so satellite resolution is 20 centimeters, and the DTM is 1 meter. The grids are different, so they land in different origins. Create the square from the DEM, force the satellite to match that grid. Confirm the DEM square size. Yes, we know that. Raster, align rasters. Match resolution, match extent. So, this is so much of a pain in the butt. We remove this layer. So we want to take the satellite, and we are going to go to raster, align rasters. Raster, align rasters. Input layer. We've been down this road before. reference layer is the DTM square. So raster align rasters reference layer is the DTM square center. And the input layer is going to be the satellite here. And it tells us there's no output file. So when we go here, same problem. Darn this. Alright, what we're going to try to do is to use the square-centered one that we made, this one, this square, and make that into the polygon for our square mask, which I did not draw perfectly. So to do that, I'm going to use a vector, research tools, and then something. So let's see what it says. Vector, research tools, extract layer extent. And I'm going to do it to a DTM square set. So vector this time, research tools, extract layer extent. The input layer is DTM squared center, and we're going to save it as extent for Unreal square mask. And then I'm going to use that all the time. And then run it. And there it is. Okay, that is the right size. I'm going to get rid of this because I don't need this anymore. And now, this satellite image is going to be cut for the square. So that part has to be cut out. So now you're going to do raster, extraction, clip it by the clip it by mask layer this time. So this is different. So this is clip it by mask layer. So we're taking the satellite, and the map layer we're using is the Unreal mask. That is all we need. And then the output is going to be, are they giving me a place to save it, or are they not giving me a place to save it? That's weird. Oh, that's what it does. It made a clipped mask. Okay. So now I can save this because this is so I can save this, export it, save as geotiff, call this satellite Olympia satellite square mask. Something like that. And say OK. And there it is. So I can get rid of this. And I have this one, which fits that, which also fits this. Square centered. Perfect. Alright. So that and the other one, which is the DSM. Can't really see. It's okay. Oh, right. Well, that was a lot of work. So now the trick is to get this into Unreal. Next step. Once the satellite is clipped to the square, we'll convert the DTM into an Unreal landscape height map. Perfect upscale 2009 and 2017. The DTM square extent already. Finish the Unreal. Yeah. So, you know what? I'm going to make this. Let's see a little bit of it. Just not going to be able to tell that, so let's make this opacity a little bigger. Alright, let's just indulge ChatGPT. Make sure we don't make any mistakes. Here, satellite lift properly. Let's see what it says. Right, so it's saying that we need to make this work for Unreal. And it's saying that we should do 1009 by 1009. Resample it. So we're going to take the DTM and we're going to resample bilinear. Let's see if that even works. Sometimes this thing doesn't know that we're in some version and gives us all sorts of crazy stuff. But the DTM square centered is what we want. And we're going to go raster. And we're going to go linear projections, warp, reproject. Now that we're in warp, we're going to source CRS, output file resolution, sampling method. It's going to be bilinear, but infinite height. There's no way to change to set output file resolution. Output file resolution. There. So this has to be set. Target your reference units. Okay, so you got to use the math. Oh my gosh. So if we want to get to 1009 times 1009, you realize you needed high school math more than ever. So it's 0.99108 meters. So that's the value that we're going to put. This is what we're going to put into the field. And then run it. Oh, God, this drives me nuts. Alright, so here we're going to put that in. We're going to run it. There's the reprojected. Didn't seem to change anything, but supposedly it did. I'm going to call this, to rename this layer, underscore DTM underscore square underscore centered underscore reprojected, and it's a temporary file until I save as geotiff. Call this whole thing Carinthia underscore DTM underscore square underscore centered underscore reprojected underscore or underscore unreal underscore 1009. Right. Might as well say that and say okay. So you can get rid of this. And then save here. Okay. Properties information. See it at 1009 by 1000. And the pixel size is now 49. So yes, raster conversion translate. I imagine I have to do the same thing for my satellite, to tell you the truth. So if I take my satellite, mass clip, I'm going to have to do a reprojection because this one is coming in at 7.2 pixel size. No, I don't know if I want to do that. I'm going to keep that mask. 15 seconds. It's always saying 15 seconds. Wow. Yes, this is driving me nuts. And do I have to warp satellite or not? Things will just translate directly pixel dimensions. Yeah. The same thing. I'm gonna trust it. I don't know. So if I pick my DTM square centered without reprojection, turn this off. That's the DSM. DTM. Where are you? There you are. DTM square centered. And it says I'm gonna do a GDAL. So where do I find that? Raster conversion translate. Now you're going to teach me a lot, don't you? Raster conversion translate. Alright. And now what? Input raster, Carinthia square centered. Just put under additional command, additional creation. Oh, this one here. Additional command line. Alright. So additional command line parameters option. Oh, I would have never known this. Outside. Output file. Just tell me to run it. So I'm going to run this. There we go. So now we got this one. If we look at the properties for this one, it is what we did before. So we didn't have to do all that math because it did it for us. So we do the same thing with the satellite. We're going to take the satellite and we are going to go to raster conversion translate and we're going to set a projection. We're going to be a satellite square mass flip. We got that. Additional parameters. That's all we need to do. So the additional command line parameters is also setting it to that. Have to remember that, and then we're going to be a texture for Unreal. So converted. Say texture for Unreal and run it. And when we check this, it is also at 1009 by 1009. So apparently that's what Unreal needs. So hey, we got this far, right? And then we're going to import from file, and let's go do that. So let's stop with this. Goodbye. Save, and let us go down to Unreal. All right, and you know what? I'm going to close out this video and start another one because this is another procedure. So see you in the next one. Hope this worked for you.